Okay, in part 2 here, we're going to learn how to multiply two numbers that are in trig form. And it's going to be a process. So here's the two I picked. Square root of 13 cosine 2 pi over 3 plus I sine 2 pi over 3. Remember, in trig form you have a modulus r cosine of an angle plus I sine of an angle. And the angles are the same. And here's another one, and we're going to take these two and multiply them together. So I'll do it like that to indicate we're going to multiply these together. Now, with that, let's see if this times this factor times this factor and times this factor times this factor. This doesn't matter what order the factors are in with multiplication. So I'm going to multiply, let me simplify this if you don't mind changing again. Let's just call it a 2. And if we multiply 2 times 8, we get 16. And what's left is this factor times this factor. So I combine the easier parts, or more obvious parts, by multiplying the 8 and the 2. And here's what's left to multiply. Alright, so let me leave the 16 out there, come back for him later, and just do my 4-step process. Alright, so I always distribute the first among the 2, and then I distribute the second among the 2, so you can do the order that you like. So I get cosine 2 pi over 3 times cosine 11 pi over 6. They're not combinable. Then I have cosine, I'm going to add the next, I'm going to do this times this, and I'm going to have cosine 2 pi, there's an I, I'll put it in front, and cosine 2 pi over 3 sine 11 pi over 6. Now I'm ready to do this. It also has an I like to put it in front. I don't lose it so easily that way. Sine 2 pi over 3 cosine 11 pi over 6. And then, if I can get the last term in view, this one times this one has an I squared, which we're used to that now. Sine of 2 pi over 3 sine 11 pi over 6. Come back in view. Alright, I had to smush. So recall, one thing we can clean up here, I squared is -1, so all that does is change this. So I am going to change that without rewriting the whole line. Forgive me. Alright. Alright, so cleaning up a little more. I see that there's an I here and an I here. And I'm going to group together the terms with an I and group together the terms without. So here's one without. I'll put at first cosine 2 pi over 3, cosine 11 pi over 6. And then this one is without. It's a negative sine 2 pi over 3. Are you noticing any pattern that is familiar yet? Come on, you can do it. Alright, then I've taken care of this one. Let me just cross it out so I realize I've already rewritten it. Now I have this term with an I and this term with an I. So I'm just going to pull the I out of those terms and put it out in front. And what's left on this term when I pull the I out? Cosine 2 pi over 3 sine 11 pi over 6. And when I pull the I out of this, what's left? Sine of 2 pi over 3 cosine 11 pi over 6. All right. Running out of room and view here. All right, now I think you might see the pattern if I exchange these. So without rewriting the whole line, let me put the sine of 2 pi over 3 cosine 11 pi over 6 first, and cosine 2 pi over 3 sine 11 pi over 6. So instead of looking at it like that, let's look at it like that. All right, drawing back a little. I don't know if we can see the whole thing at once. Do you see anything? Imagine this was A and this was B. Do you see cosine A, cosine B minus sine A, sine B? There is a trig ID. All right, so putting my 16 back here. Let's hope this shows up from this distance. We know that cosine cosine minus sine sine is like cosine A cosine B minus sine A sine B. So looking at my trig IDs, look at yours. Cosine cosine minus sine sine is cosine of A plus B. So I can rewrite this whole relationship as cosine of A plus B. 2 pi over 3 plus 11 pi over 6. All right. We'll clean that up in a little bit. I is out in front here. Do you recognize this one? Sine cosine plus cosine sine. Sine A cosine B plus cosine A sine B. Well, that is sine of A plus B. So I'll just sine of this plus this. 2 pi over 3 plus 11 pi over 6. So what is this? Well, this is 4/6. 4/6 plus 11/6 is 15/6. And 15/6 can be reduced by a factor of 3. So 5 halves. Halves? 5 halves? 5 halves, yeah. So 16 cosine, and this becomes 5 halves pi. I divide that by 3, I get 5, that by 3, I get 2. I don't know why that's coming slowly. All right, and then this one is also 5 halves pi as well. So we have now multiplied the two numbers. And I can hear some of you now saying, I don't like this. Well, you're about to like it. So there. Is there a way I could have gotten very, very quickly from this step to this one? Patterns, patterns, patterns. What is math except patterns? So here's the original problem. Let me draw it out again. We're multiplying this complex number times this one. All right, so when I do that, I want to get from this to the 16. Easy peasy, just take the modulus and the modulus. I'm sure there's a plural of modulus, but I don't know what it is. Moduli, moduluses. All right, 16. And what happens here? How could I get this number quickly, the 5 halves pi? Well, I know trig form is going to be r cosine theta, I sine theta, because we were repeating that to ourselves a lot. So I've got the r part, but how do I get the theta part very quickly from the original problem? Notice this answer is this plus this. So I'm going to do cosine 2 pi over 3 plus 2 plus, oops, did I write this wrong? Nope. 2 pi over 3 plus, we're going to add this one with this angle, sorry, 11 pi over 6. And that we have shown in a step previously that does come out to 5 pi over 2. And then this angle is the same. So the final answer is 16. I'll clean it up and smush it in here. 16 cosine 5 pi over 2 plus I sine pi over 2. And hopefully that getting from here to here was a little easier than getting through the whole long way. So for example, if I had two numbers that were complex, say I have 3 cosine 30, they can be in degrees, plus I sine 30, but remember in trig form the two angles are the same. And then I'm multiplying that, say, by 6 cosine 45, I sine 45. Seeing the patterns, we can multiply these two complex numbers in trig form by multiplying the modulus, 6 times 3, and adding the angles, 30 and 45 is 75, and the I sine 75. So that's how quick we can multiply. Just a note before I sign off, division. If we were going to divide, say, this number by this one, 6 cosine 45, I sine 45, we're going to do a similar step. And I'm not going to show you why, because it only follows a similar pattern. Cosine 30, I sine 30. I'll just show you the quick way. You're going to divide the modulus, 2, and you're going to subtract the angles. So cosine of 45 minus 30, and the angles are the same. Oops, my sign disappeared. 2 cosine 15 plus I sine 15. So it's done. So on class on Monday, I'll show you how to take roots of these complex numbers, which is just as quick. All right, you survived the addition and multiplication, division of complex numbers in trig form. I'm so proud of you. Have a good rest of your weekend. See you in the morning on Monday. Over and out.